Today we're diving into the fascinating world of tokenization. If you've ever wondered how computers break down text into manageable pieces, you're in the right place. Tokenization is a crucial first step in many natural language processing tasks, helping machines understand and process human language. In this video, we'll walk through the step-by-step process of tokenizing text, making complex concepts easy to grasp. Whether you're a beginner or just looking to refresh your knowledge, this journey will clarify how raw text transforms into tokens that computers can work with. Let's get started by understanding what tokenization really means. Tokenization is the process of breaking down a stream of text into smaller pieces called tokens. These tokens can be words, characters, or even subwords depending on the application. Think of it as slicing a loaf of bread into individual pieces so it's easier to handle. In language processing, tokenization helps computers identify the basic building blocks of text, making further analysis possible. This step is essential for tasks like text classification, sentiment analysis, and machine translation. Now let's explore why tokenization is so important in the world of text processing. Tokenizing text is a foundational step in natural language processing because it simplifies complex language into manageable units. By splitting sentences into tokens, computers can analyze, search, and manipulate text more efficiently. Imagine trying to analyze a book without separating it into words or sentences. It would be nearly impossible. Tokenization enables more advanced processing, such as identifying keywords, extracting information, and understanding context. With this groundwork laid, let's move on to the first step in the tokenization process, preparing the raw text. Tokenization process always starts with raw text. This could be anything from a tweet to a lengthy article. Before tokenizing, it's important to ensure the text is in a consistent format. This might involve removing unwanted characters, converting all letters to lowercase, or handling special symbols. Clean, well-prepared text makes the next steps much smoother and more accurate. Once the text is ready, we can begin breaking it down into tokens. Let's see how the next step unfolds. After preparing the text, the next step is often to split it into sentences. This is especially useful for tasks that require sentence-level analysis. Sentence splitting involves identifying punctuation marks like periods, exclamation points, and question marks. By breaking the text into sentences, we create manageable chunks that can be further tokenized into words or subwords. This step helps maintain the structure and meaning of the original text, making downstream processing more effective. Once sentences are identified, the next step is to break each sentence into words. This is called word tokenization. It's one of the most common forms of tokenization and is essential for many language processing tasks. Word tokenization typically involves splitting text at spaces and punctuation marks. For example, the sentence "tokenization is fun" would be split into the tokens "tokenization is" and "fun." This step lays the foundation for further analysis, such as part-of-speech tagging or sentiment detection. Punctuation can be tricky during tokenization. Should punctuation marks be treated as separate tokens or attached to words? The answer depends on the application. For some tasks, it's important to keep punctuation separate as it can change the meaning of a sentence. For others, punctuation might be ignored. Tokenization tools often provide options to customize how punctuation is handled, ensuring the output fits the needs of your project. Next, let's look at how tokenization deals with special cases. Tokenization isn't always straightforward. Special cases like contractions, hyphenated words, or abbreviations can complicate the process. For example, should "don't" be split into "do" and "ent" or kept as one token? How about email or USA? Tokenization tools use rules or machine learning to handle these cases, ensuring tokens make sense in context. Handling special cases correctly improves the quality of downstream language processing tasks. Sometimes breaking text into words isn't enough. Subword tokenization splits words into even smaller units, like prefixes, suffixes, or syllables. This is especially useful for languages with complex word forms or for handling rare words. Subword tokenization helps models understand and generate new words by recognizing patterns within words. It's widely used in modern language models, such as those powering machine translation or text generation. In some cases, tokenization goes down to the character level. Character tokenization splits text into individual characters, which can be useful for languages without clear word boundaries or for tasks like spelling correction. While this approach creates a large number of tokens, it allows for very fine-grained analysis. Character tokenization is often used alongside other methods to capture all possible nuances in the text. There are many tools available for tokenizing text, ranging from simple scripts to advanced libraries. Popular options include NLTK, SPACI, and the tokenizers used in transformer models. These tools offer different features, such as customizable rules, support for multiple languages, and integration with other text processing tasks. Choosing the right tool depends on your project's requirements and the complexity of the text you're working with. Rule-based tokenization relies on predefined patterns and rules to split text into tokens. For example, it might use spaces, punctuation, or regular expressions to identify token boundaries. This approach is straightforward and works well for simple texts. However, it can struggle with complex language or special cases, making it less flexible than more advanced methods. Machine learning-based tokenization uses algorithms trained on large datasets to identify token boundaries. These models can learn complex patterns and handle special cases more effectively than rule-based methods. Machine learning tokenizers are especially useful for languages with ambiguous or irregular structures. They adapt to new data and improve over time, making them a powerful choice for modern language processing. Let's look at a practical example. Suppose we have the sentence, "Tokenization makes text processing easier." A tokenizer would split this into the tokens. Tokenization makes text processing easier. Each token can then be analyzed or processed further, This simple example shows how tokenization lays the groundwork for more advanced text analysis. Tokenization isn't one size fits all. Different languages have unique rules and structures which can affect how text is tokenized. For example, Chinese and Japanese don't use spaces between words, making tokenization more challenging. Specialized tokenizers are designed to handle these languages, using dictionaries or machine learning to identify word boundaries. Understanding language-specific challenges is key to effective tokenization. One of the simplest tokenization methods is whitespace tokenization. Here, text is split into tokens wherever there's a space. While this works well for many languages, it can miss important details like punctuation or compound words. Whitespace tokenization is fast and easy to implement, making it a common choice for basic tasks or quick prototypes. Regular expression tokenization uses patterns to identify tokens in text. For example, a regular expression can match words, numbers, or punctuation marks. This method is more flexible than simple whitespace tokenization and can handle a wider range of cases. However, it requires careful design to avoid splitting tokens incorrectly or missing important details. Tokenization often goes hand in hand with text normalization. Normalization involves converting text to a standard format, such as lowercasing all letters or removing accents. This step ensures that tokens are consistent and comparable, reducing errors in downstream processing. Combining tokenization with normalization creates a strong foundation for accurate language analysis. Search engines rely heavily on tokenization to index and retrieve documents. By breaking text into tokens, search engines can match user queries with relevant documents more effectively. Tokenization also enables features like autocomplete and spell correction, improving the search experience. Accurate tokenization is essential for delivering fast and relevant search results. Machine translation systems use tokenization to break down sentences before translating them into another language. By analyzing tokens, translation models can better understand sentence structure and meaning. Subword tokenization is especially useful here, as it helps handle rare or unknown words. Effective tokenization leads to more accurate and fluent translations. Sentiment analysis tools use tokenization to break text into words or phrases, making it easier to detect positive or negative emotions. By analyzing tokens, these tools can identify sentiment-bearing words and phrases, providing insights into how people feel about a topic. Accurate tokenization ensures that sentiment analysis captures the true meaning of the text. Chatbots rely on tokenization to understand and respond to user messages. By breaking input text into tokens, chatbots can identify user intent, extract key information, and generate appropriate responses. Tokenization helps chatbots handle a wide range of queries, from simple questions to complex conversations, making interactions smoother and more natural. Text summarization tools use tokenization to break down long documents into manageable pieces. By analyzing tokens, these tools can identify the most important sentences or phrases, creating concise summaries. Tokenization ensures that summaries capture the main ideas without losing essential details, making information easier to digest. Text classification systems use tokenization to convert raw text into features that can be analyzed by machine learning models. By splitting text into tokens, these systems can identify patterns and categorize documents based on their content. Accurate tokenization improves classification accuracy, helping systems sort emails, news articles, or social media posts efficiently. Named entity recognition (NER) systems use tokenization to identify names of people, places, organizations, and more within text. By breaking text into tokens, NER tools can accurately pinpoint and label entities, enabling applications like information extraction and knowledge graph building. Effective tokenization is key to high-quality entity recognition. Speech recognition systems convert spoken language into text, which is then tokenized for further analysis. Tokenization helps these systems understand sentence boundaries, word usage, and context, improving transcription accuracy. By breaking down transcribed text into tokens, speech recognition tools can deliver more reliable and meaningful results. Text generation models, like those used in chatbots or creative writing tools, rely on tokenization to produce coherent sentences. By generating tokens one at a time, these models can create text that flows naturally and makes sense in context. Tokenization ensures that generated text maintains proper grammar and structure. Information retrieval systems such as digital libraries or search engines use tokenization to index and retrieve relevant documents. By breaking text into tokens, these systems can quickly match user queries with stored information, making it easier to find what you're looking for. Tokenization is a key component of efficient and accurate information retrieval. Spell checkers use tokenization to break text into words, allowing them to check each word for spelling errors. By analyzing tokens, these tools can suggest corrections and help users write error-free text. Tokenization ensures that spell checkers can handle complex sentences and catch mistakes accurately. Some contexts, tokenization refers to replacing sensitive data with non-sensitive tokens to protect privacy. While this is different from text tokenization, both processes involve breaking down information into smaller parts. Data privacy tokenization is widely used in finance and healthcare to secure personal information, ensuring that sensitive data is never exposed. Tokenization isn't without its challenges. Ambiguous language, slang, and evolving usage can make it difficult to define clear token boundaries. Different languages and writing systems add further complexity. Overcoming these challenges requires a combination of rules, machine learning, and continuous adaptation to new data. Despite these hurdles, tokenization remains a vital step in text processing. How do we know if tokenization is working well? Evaluation involves checking if tokens match expected boundaries and make sense in context. This can be done manually or with automated tests. High-quality tokenization improves the accuracy of downstream tasks, while poor tokenization can lead to errors and misunderstandings. Regular evaluation helps maintain the effectiveness of tokenization tools. Tokenization tools are constantly evolving. Developers improve tokenization by updating rules, training models on new data, and incorporating user feedback. Advances in machine learning and natural language processing continue to push the boundaries of what tokenization can achieve. Staying up to date with the latest tools and techniques ensures the best results for your projects. Deep learning models, such as transformers, rely on advanced tokenization methods to process text. These models often use subword or byte pair encoding to handle large vocabularies and rare words. Tokenization enables deep learning models to understand context, generate text, and perform complex language tasks with high accuracy. Tokenization is often the first step in text preprocessing pipelines. After tokenizing, text may be further processed with steps like stemming, lemmatization, or stopword removal. Each step builds on the tokens created during tokenization, making it a critical foundation for any text analysis workflow. Sometimes, standard tokenization tools don't fit your needs. Custom tokenization rules can be created to handle domain-specific language, jargon, or unique formatting. By tailoring tokenization to your data, you can improve accuracy and ensure that tokens make sense for your specific application. Social media text presents unique challenges for tokenization. Slang, emojis, hashtags, and abbreviations require special handling. Tokenization tools for social media often include rules for splitting hashtags, recognizing emojis, and dealing with informal language. These adaptations help capture the full meaning of social media posts. Tokenizing programming code is different from natural language text. Code tokenizers split source code into keywords, operators, identifiers, and symbols. This process helps compilers and interpreters understand and execute code correctly. Accurate tokenization is essential for tasks like syntax highlighting, code analysis, and automated testing. Multilingual text requires tokenization tools that can handle multiple languages at once. These tools must recognize different scripts, punctuation rules, and word boundaries. Multilingual tokenization is essential for global applications, ensuring that text is processed accurately regardless of language. Legal and medical texts often contain specialized language and formatting. Tokenization tools for these domains include rules for handling citations, abbreviations, and technical terms. Accurate tokenization ensures that important information is preserved and can be analyzed effectively for research or compliance purposes. E-commerce platforms use tokenization to process product descriptions, reviews, and customer queries. By breaking text into tokens, these platforms can match products to search terms, analyze customer feedback, and personalize recommendations. Tokenization helps e-commerce businesses deliver better user experiences and drive sales. Education technology platforms use tokenization to analyze student responses, grade essays, and provide personalized feedback. By breaking down text into tokens, these systems can assess writing quality, detect plagiarism, and tailor learning materials to individual needs. Tokenization supports more effective and adaptive educational tools. Content moderation systems use tokenization to detect inappropriate or harmful language in user-generated content. By analyzing tokens, these systems can flag offensive words, phrases, or patterns, helping keep online communities safe and welcoming. Tokenization enables fast and accurate content filtering at scale. Analytics platforms use tokenization to break down large volumes of text data for analysis. By creating tokens, these platforms can track trends, measure sentiment, and uncover insights from customer feedback, social media, or surveys. Tokenization turns unstructured text into actionable data for business intelligence. Wrap-up tokenization is a fundamental process in text analysis, enabling computers to break down and understand human language. From simple whitespace splitting to advanced machine learning methods, tokenization supports a wide range of applications, from search engines to chatbots. By mastering tokenization, you lay the groundwork for more advanced natural language processing tasks. Thanks for joining us on this step-by-step journey through tokenization. We hope you now have a clear understanding of how tokenization works and why it's so important in today's digital world.